Information in various forms has been an integral part of our lives since the beginning of mankind. Information is what we use to understand our past and shape our future. We have been gathering information over thousands of years of our existence and passing it on through our generations. Sometimes we have used information for our betterment and sometimes for our destruction. The concept of computing dates back to the time when we could first count. We used various computing techniques to generate information. For example, we used the position and movement of galactic objects such as the sun, moon and stars to compute time and predict weather conditions. As the human race evolved and life became more complex, the need for information grew. Consequently, the need for tabulating and storing this information also grew. An early manual calculating device was the abacus. It is still used today in some parts of the world. Information gathering and record-keeping techniques continued to develop through the centuries. The Greeks' innovations gave us the concept of record audits, and the Romans gave us the concept of budgets. In 1642, a young Frenchman named Blaise Pascal developed a mechanical calculating machine. Over the years, people improved on this device and made it capable of adding, subtracting, multiplying and dividing numbers. As the quantum of information grew, there was a need for processing this information faster. Traditional methods that involved processing data using pencils, pens and rulers were too slow to fulfill this need. For example, the United States Census Bureau took almost 10 years to process the census data it had gathered in 1880. In 1887, a statistician named Herman Hollerith developed a machine-readable card concept and designed a device known as the census machine. This machine helped complete the census count in 3 years. By 1950, the census count could be completed in 2 years despite the growth in population. By 1980, with the use of better technology, the same could be achieved in a few months. In 1896, Herman Hollerith founded the Tabulating Machine Company to commercialize his invention and later merged this firm with others to form the International Business Machines or IBM Corporation, which is today the largest computer company in the world. In 1946, John W. Moseley and J. Presper Eckert Jr. built the first electromechanical computer, the Electronic Numerator Integrator Analysis and Computer, or the ENIAC. It weighed about 30 tons, occupied the space of a 3-bedroom house, and could do 300 multiplications per second. A major drawback of the ENIAC was that it heated up very fast and had to be frequently shut down to cool off. The ENIAC was followed by the Electronic Discrete Variable Automation Computer, or the EDVAC. The EDVAC used punched cards and was able to store programs. There were many problems associated with first-generation computers. They were bulky, slow, and used to heat up very fast. Further research resulted in the development of smaller and faster computers. The use of higher-level programming languages started being preferred over cumbersome and complicated machine languages. Compact, solid-state components like the transistors that had been developed at Bell Laboratories in 1947 replaced the bulky vacuum tubes that were used in first-generation computers. Transistors and other components were integrated into circuits and placed on small chips of silicon, thus giving birth to the integrated circuits industry. Robert Noyce and Jack Kilby are credited with developing the first integrated circuit. Robert Noyce was also the founder of Intel Corporation, makers of the Pentium processors that make the heart of the modern PC, among other things. Since many companies in the Santa Clara Valley were manufacturing integrated circuits, the region became known as Silicon Valley. Second-generation systems were highly specialized and were designed to process either scientific or non-scientific applications, but not both. In 1964, IBM launched a third generation of computers, the System 360 family of mainframe computers. This computer could handle the execution of a large set of built-in instructions. Thus, it was possible to efficiently handle scientific processing as well as record-keeping applications simultaneously. Since 1964, many similar and superior processors have been developed to further enhance computing capability. These superior processors could have been considered as the fourth generation of computers, but the industry failed to agree to this classification of generation. Mainframe computers were expensive and were designed to process information at a central location. These characteristics helped serve the needs of large organizations, but not that of smaller ones that could not afford them. Additionally, certain applications needed localized information processing, which mainframes could not provide. There was clearly a need for low-cost computers that need not be as fast as mainframes, but provided similar processing capabilities. In 1965, Digital Equipment Corporation, or DEC, provided a solution in the form of a mini computer. Similar products from other majors such as Hewlett-Packard and Data General quickly followed. After 1965, the average number of electronic components packed on a silicon chip doubled each year. This speed of miniaturization led to the development of a microprocessor that could be placed on a single chip. A microprocessor contains all the circuits needed to perform the two most important functions of a computer: arithmetic logic and control functions. The microprocessor, which was initially used in calculators, evolved over time and became faster. In 1974, Intel developed a microprocessor, the 8080, and thus laid the foundation stone for the development of a personal computer, or PC. MITS Incorporated was one of the pioneers in the personal computer and introduced the Altair 8800 product that was based on an Intel processor. Around 1975, two young programmers named Bill Gates and Paul Allen were working on a program that translated instructions written in BASIC, or the beginner's all-purpose symbolic instruction code, to the machine codes required by Intel microprocessors. They created Microsoft Corporation to market their BASIC program and licensed it to MIT in 1975. Today, Microsoft is the world's largest supplier of PC software. In 1976, Steve Wozniak, a young technician from Hewlett-Packard, built a computer using a microprocessor from MOS Technology. When Hewlett-Packard did not show interest in Wozniak's computer, the Apple I, he tied up with Steve Jobs, and together they formed Apple Computer. Apple Computer then proceeded to become a major player in the personal computer industry. The real boom in personal computers came when IBM introduced its IBM PC family of computers in 1980. Since then, there has been no looking back. Personal computers have become an indispensable aspect of individuals as well as organizations. There are some basic differences between computers based on their application, size, and design. Computers can be used to count numbers or measure physical quantities. Based on their application, computers can be classified as digital computers, analog computers, hybrid computers. A digital computer is one that directly counts numbers that represent alphabets, numerals, or other special symbols. In contrast, an analog computer measures physical quantities such as temperature or pressure. A hybrid computer is created when relevant functions of digital and analog computers are combined to meet a desired objective. A good example of a hybrid computing system is a combination of analog devices such as those that measure a patient's heart function and other vital signs linked to digital components that monitor these functions. Most of the computers in use today are digital devices. Processors installed in automobiles to control fuel, ignition, and braking systems are examples of such devices. These devices are often referred to as special-purpose digital computers as they perform specific functions. There are computers that can perform one function based on a certain set of instructions and yet others based on a different set of instructions. In other words, they are so versatile that they can be programmed to perform any desired function, and such functions are limited only to human imagination. Such computers are referred to as general-purpose digital computers. The personal computer is probably the best example of a general-purpose digital computer. Computers are also classified according to their sizes. Mini computers and microcomputers are typically smaller in size than mainframe computers. Microcomputer sizes range from the size of a notebook to a size that can occupy a sizable portion of your desktop and typically serve one user. Mini computers are larger in size and typically serve multiple users. They are faster than microcomputers and offer larger storage facilities. Mainframe computers are even larger than mini computers. Naturally, they are also faster and offer even larger storage facilities than mini computers. Supercomputers, as the name suggests, are by far the largest and fastest computers known to mankind. They are used in processing complex scientific applications. All computer systems are made up of hardware components and are intended to process information. They accept specific input, process this input based on the way they are programmed, and produce desired output on various media. Computer circuits were made up of a combination of electronic components such as transistors and other items. Thousands of such circuits are now integrated and packaged on small silicon chips measuring about a quarter of an inch. Since 1965, the number of electronic components packaged on a chip has been doubling each year. Such small-scale integration efforts evolved to large-scale integration or LSI chips that contain thousands of components. Over the years, due to efforts from the industry to bring in more miniaturization and the hunger for faster processing, came the very large-scale integration or VLSI chips. These chips contain hundreds of thousands of components. As the size of computer components decreased, their speed increased and cost decreased. Similar advances have been made in the storage capacity and reliability of computers. Storage capacity of both primary and online secondary storage units has increased thousands of times over the years. Today's computers can run for years without failure, in contrast to earlier computers that broke down every few hours. Not to be left behind, tremendous gains have been achieved in the development of computer software. Programming has changed from writing complex machine instructions to writing in a form easier for humans to understand. This was achieved by developing programs that translated simple English-like programs to the complex machine language required by computers to function. Most of us know that a computer is a fast calculator. A computer performs its functions one step at a time. What is significant is that it performs these steps very fast. For example, to perform basic operations such as adding or subtracting, a small computer takes a few microseconds or a millionth of a second. Larger computers perform the same operations in a few nanoseconds, which is the billionth of a second. Additionally, computers perform these operations very accurately. Computer circuits have no mechanical parts and are therefore not prone to wear and tear or malfunction. Consequently, in spite of performing millions of operations every second, computers can work for days without making errors. There is, however, one important aspect to be considered with regard to a computer's speed and accuracy: input data. Computers process information that they have been fed. If your input data or programs are correct, you can expect the computer to churn out your desired output. However, if you have made errors in feeding it with the right data or programs, you can be guaranteed to receive output that is meaningless. Perhaps the best way to understand this characteristic of computers is to understand the phrase garbage in, garbage out, or GIGO. It is therefore easy to understand that computer errors are caused by humans and not because of any shortcomings of computers. Computer processing involves manipulating symbols such as letters and numbers that people use to represent things. A computer accepts raw input data, processes it, and outputs meaningful information that helps people achieve specific purposes. The interpretation of this information is generally dependent on human judgment, and this varies from person to person. That is why information for one person may only be meaningless data to another. Essentially, data processing consists of three basic activities: capturing input data, manipulating the captured data, managing output results. Input data must be first captured in some form before it can be processed. This can be achieved by using a variety of devices such as keyboards, mice, scanners, automated teller machines, etc. A stored computer program then instructs the computer to perform operations such as classifying, calculating, sorting, or summarizing the input data. The result of such data manipulation can now be output as meaningful information by using devices such as computer monitors or printers. The output data can also be stored onto storage devices for future reference or further processing. Or it can be transferred from one location to another location using data communication devices such as modems. Computers are the most powerful tools ever developed to process information. But they do only what people program them to do. No computer system will perform adequately without correct input data, reliable programming, and sound logic. Computers cannot assume what you had in mind when you feed it with incorrect data and programs. The computer can only perform jobs that are clearly defined in a stepwise manner leading to a specific goal. Computers may not be very helpful in making subjective evaluations. For example, a computer cannot tell a student whether he will pass his exams. It can, however, based on how it is programmed, give the student practice examinations and increase his mastery over a subject. Computers are one of the most powerful forces in society today. They're being used in homes and organizations, making a significant impact on people. People are caught up in an information revolution, and the computer is the driving force behind it. Undoubtedly, as in any revolution, there are bound to be positive and negative effects of computer usage on people. People of all professions use computers for their benefit. Computers help people become more efficient by carrying out repetitive tasks fast and accurately. Computers help improve the quality of products and services we receive. Computers serve us as excellent educational and recreational tools. Scientists use computers to assist them in researching complex problems which otherwise would have been difficult or impossible. Lawyers and doctors refer the vast repositories of online databanks to perform their duties better. Similarly, students refer the large databanks of educational content to enhance their knowledge. On the other hand, computers, when used irresponsibly, cause harm to people. On many occasions, people are required to fill out forms containing personal information when applying for credit cards, insurance, employment, etc. This information is then fed into computer systems for analysis and approval purposes. There are various possibilities of misuse of this information. For example, some agencies sell this information to other organizations that wish to benefit from it. Sometimes this information is stolen from the computer systems and misused by miscreants. There are also possibilities of wrong data being transferred from forms to the computer due to human error. For example, a credit card company may not issue a credit card to an applicant if the applicant's income has been wrongly entered into the computer, despite it being filled correctly onto the form. Organizations involved in areas such as government, healthcare, business, science, engineering, education, etc. are heavy users of computers. Governments use computers for planning, control, and law enforcement activities. Computers have helped the healthcare industry save lives and serve patients better. The use of computers in education is increasing at a rapid pace. Businesses use computers to become more competitive, make better products, and serve their customers more efficiently. Computer graphics and sound capabilities are helping redefine the entertainment industry. Computers process thousands of scientific applications daily to give us the latest weather forecast. Computer-controlled devices such as conveyors, driverless cars, and robots are used in automating the material handling systems in the manufacturing and transportation industry. Computers are also used in designing products, managing production, and testing various equipments and components. Like people, organizations too are prone to dangers from the use of computers. Theft of financial information can lead to heavy financial losses. Theft of intellectual property such as product designs, manufacturing processes, etc. can result in unfair advantages from competing organizations. Computerization efforts sometimes involve organizational restructuring. Restructuring may result in people losing their jobs or being shifted to different departments. This causes stress to people and ultimately results in losses to the organization by way of decreased efficiency, resistance to change, property damage, etc.